Think about a massive argument you once had, where you knew you were right and the other person was completely wrong. What if science just proved that you were both telling the absolute truth because you are literally not sharing the same reality? What if the face of the person sleeping next to you physically stops existing the second you turn off the light? What if your most precious memory mathematically never happened until the exact moment you just tried to remember it? In the last few years, modern physics has completely destroyed the concept of a shared, objective world. The experiments are done. The results are in. Quantum mechanics has officially proven that the physical universe is fundamentally broken. The solid world you trust is hiding a terrifying mathematical void. And to make it worse, you have never, not even once in your life, actually experienced the present moment. To understand this quantum nightmare, we first need to break down how your own brain is actively faking the data, and how it influences the fundamental physics of reality itself. And it does it ruthlessly. Every year, thousands of people leave this life because someone was looking straight at the thing that could have saved them and did not see it. A driver checks the intersection, pulls out, and drives straight into a car that was right there the whole time. A doctor reads a scan, says it is clean, and the patient goes home with a tumor no one spotted. And these are not tired people making sloppy mistakes. Their eyes worked fine, the information came in. But somewhere between the eye and the brain, the thing that was there got erased. So if information gets erased, then all of us are at constant risk. How then do we trust ourselves? And what makes the information get erased? In 2013, a researcher at Harvard named Trafton Drew was testing exactly this. He took a lung CT scan, the kind radiologists read every day, and hid an image of a gorilla inside it. Not a small one. 48 times the size of a tumor nodule, he gave the scan to 24 trained radiologists and asked them to look for cancer. Eye tracking showed every single one of them looked directly at the gorilla. 83% did not see it. Not because they were careless, because their brain was looking for nodules, and a gorilla is not a nodule. So the brain threw it out. That was a test. Nobody was hurt. But those same brains read real scans every day. And a tumor that shows up where the textbook said it should not be gets handled the same way that gorilla did. It gets deleted. The patient walks out with a clean result. Not because nothing was there, because the brain doing the reading was not expecting what was there. So how does information actually get deleted? Karl Friston at UCL answered this in 2006, and what he found is that the brain does not wait for the eye to see. It runs a model of what should be out there and compares incoming signals against that model. Anything that fits gets waved through. Anything that does not fit gets cut. Think of it this way. You walk into your kitchen every morning. The brain already knows where the table is, where the window is, where the light falls. It does not rebuild the kitchen from scratch. It loads the version it already has. If someone moved a chair overnight, you might walk right past it and not notice for hours. Not because your eyes missed it, because the brain checked the chair against its model, the model said nothing changed, and the real chair lost. And that is not just kitchens or radiology, that is everything. The face of the person you love might not look the way you think it does. The symptom you checked on your own body and decided was nothing might not have been nothing. Every important decision you have ever made was made on a picture your brain built, not on what was actually there. But that is only half of it, because erasing is not the worst thing the brain does. The worst thing is what it puts in place of what it erased. So what if somewhere on the street you look into the eyes of a psychopath, and he seems like a good, pleasant person, only because he resembles someone you know? That is, our brain has the property of substituting information. Or do you think the brain broadcasts reality to you as it is? Then how do you explain the famous door test? This test was conducted by Daniel Simons and Daniel Levin in 1998. The essence of the experiment is this. Imagine you are asking a passerby for directions. A massive door is carried between you and, at that moment, the passerby is switched for another person. Different height, different voice, different face. Can you guess how many people notice the switch? 75% continue the conversation as if nothing happened. How is that possible? So, if the brain can miss a whole person being swapped in broad daylight, then how do we know we will catch the things that actually matter? A car flying into our lane, a deadly symptom hiding on a scan, the lie in the eyes of someone we love. How many of those moments have you already missed? You will never find out, will you? The brain does not flash an error message. It just paints over the hole with whatever seems right and moves on. And you want to hear something worse. The signal from your retina to your visual cortex takes 80 milliseconds. You know what that means. At 60, a car covers a full meter in that time. You have never once in your life seen the present moment. Every emotion you have ever felt was a response to something that was already over. Your entire life has been lived on tape delay. So we cannot trust our eyes because the brain invents half the picture. We cannot even trust the half it lets through because everything arrives late. But maybe at least the world itself is real, not distorted. Maybe things keep their shape even when our brain is glitching this badly. And two mathematicians decided to test exactly that in 1967. To understand what those mathematicians found, imagine the room behind your back is completely empty right now. No walls, no furniture, nothing at all until you turn your head. That is, the moment you turn around, everything sort of appears. Sounds like nonsense, but in 1967, mathematicians Simon Kochen and Ernst Specker ran an experiment. They wanted to know if a tiny quantum particle has all its settings figured out before we look at it. Imagine a glitchy smartphone. If you turn on the Wi-Fi, the camera stops working. If you fix the camera, the screen goes black. You physically cannot have all the features working at the exact same time. They proved mathematically that our universe has the same glitch. You can't lock down all of a particle's properties in advance because the rules cancel each other out. A particle literally doesn't have a final state until the exact moment you check. Everyone has heard of Schrödinger's cat. Alive and dead at the same time. Kochen-Specker is worse. The cat does not have a state at all. No alive, no dead. Nothing until someone opens the box. And do you understand what that actually means? If properties do not exist before you check, then measurement does not show you reality. It creates reality. The act of looking is not reading. It is writing. Every time a physicist points an instrument at a particle and gets a result, that result did not exist a second earlier. The instrument did not find it. The instrument produced it. So what is left between measurements? Not a fuzzy version of the object, not a thing with hidden qualities. Between measurements, there is no object. There is empty potential that becomes real only at the moment of interaction. The universe, when no one is looking at it, is not uncertain. So measurement literally creates reality out of nothing. Nothing physical exists until something asks it to. But if the material world itself is this hollow, then what are we supposed to hold on to? What about numbers? At least they should be unchanging. After all, it is called an exact science for a reason. Can we at least be absolutely sure that 1 + 1 is 2? Imagine you put 3 apples into 2 boxes, open them, and somehow neither box has 2 apples in it. How is that even possible? In 2014, physicist Yakir Aharonov and his team at Chapman University set up a quantum experiment. They took 3 photons and sent them into a system with only 2 possible paths. It is like 3 people checking into a hotel with only 2 rooms available. In normal physics, at least 2 objects must end up in the same place. But when they measured the photons, something impossible happened. They checked every pair of paths and never once found 2 photons on the same one. 3 particles, 2 paths, and no 2 particles ever share a path. They repeated it hundreds of times with the same result, and the math has been verified independently by multiple teams. Basic arithmetic just stops working at the quantum level. So what broke? Not the experiment. Our assumption that objects sit in a definite place before we look. At the very bottom of reality, 1 + 1 no longer equals 2. The rules we use to make sense of this world simply do not apply down there. Think that is as crazy as it gets. And here is another one. Imagine your smile stayed hanging in the empty room you just walked out of. In the normal world, you can't separate an object from its features. But in 2013, a team at the Vienna University of Technology broke this rule. They shot a single neutron into a system with 2 paths. When they checked the data, the physical body of the neutron went down the left path, but its spin, its actual rotating motion, went down the right. Imagine throwing a ball. The ball flies left, but its spinning motion flies right, completely on its own. They successfully ripped a physical property away from its particle. The particle went one direction and its feature went the other. Like the Cheshire Cat leaving its grin behind. Except this is not a fairy tale. This is a real experiment in a modern lab. Do you understand what that means? Properties do not just fail to exist before measurement, they are not even attached to their objects. A property can rip away from the thing it belongs to and show up somewhere the object is not. So what do we have? We thought the material world was solid and straightforward. It is not. Properties do not exist until observed. Arithmetic is broken at the base, and the qualities of things drift on their own with no fixed address. But let us grab the last straw. At least all of this is happening right now, in the present. Surely we can trust that much. Our past is locked in. The things that happened yesterday actually happened. Right. But one physicist proved that this is not the case. In 1985, physicists Anthony Leggett and Leggett-Garg designed an experiment to test if the past actually happens when no one is watching. They took a quantum particle that can only spin in 2 directions, clockwise or counterclockwise, and they checked which way it was spinning at 3 different moments. If that particle is always spinning in some direction, even when you aren't looking, the results of your 3 checks are mathematically limited. Think of the weather. If Monday's weather matches Tuesday, and Tuesday matches Wednesday, then Monday and Wednesday cannot be completely opposite every single time. That's not quantum physics, that's just basic logic. Leggett and Garg turned this into a precise formula. They calculated a number called K, which measures how well all 3 checks agree with each other. If the particle physically exists and spins between your checks, K can never be higher than 1. That is the absolute ceiling. But when physicists ran the experiment, K came back at 1.5. That is 50% above the maximum limit. Imagine a car's speedometer maxing out at 100, but the car is somehow doing 150. It's a brutal violation of reality. The only mathematical way to get a number that high is if the particle was not spinning in any direction between checks. Not clockwise, not counterclockwise. It was nothing. Do you smell what that means? Between measurements, there was no state. Not because the instruments were bad. The past in which the particle had any properties at all never existed. There was no past to measure. The past only appeared the exact moment someone looked. Let us add up the damage. Kochen-Specker proved properties do not exist before measurement. The quantum pigeons proved that basic math falls apart at the bottom of reality. The Cheshire Cat showed that properties peel off their objects and drift on their own. And now Leggett and Garg proved that the past where all of this supposedly sat was never there either. The world beyond your skull. It is a total vacuum that assembles itself pixel by pixel only where you point your attention right now. And where you are not asking the question, there is nothing. Okay, so the brain hallucinates the picture from the inside, and the outside is a void with no properties. But at least we are all seeing the same illusion. We agree on facts. We share the same events. Surely there is something solid and objective between us. In 2018, 4 physicists decided to test this last hope. Imagine you and someone close to you are looking at a building, and out of nowhere you say, "Wow, I love the architecture of this building. A perfect square." But your partner starts arguing with you because they see a rectangular building. Yes, the example is strange, but The most interesting and terrifying part is that from the point of view of physics, you are both absolutely right. You are in your reality and your partner is in theirs. Absurd. How can that even be possible? In 2018, physicists Daniela Frauchiger and Renato Renner at ETH Zurich designed an experiment that has been driving scientists insane ever since. Here is how it works. There are 4 people. 2 of them sit inside sealed laboratories where they cannot communicate with the outside. 2 stand outside. The person inside Lab 1 receives a single quantum particle. She measures its spin, clockwise or counterclockwise. The device gives her a clear answer. She writes it down on paper. For her, the experiment is done. The spin is clockwise. That is a fact. Finished. But the person standing outside her lab does something different. He measures the entire lab, the walls, the equipment, the air, and the woman inside it, all as one giant quantum system. Because from the point of view of quantum mechanics, when the woman began observing the particle, they sort of took on each other's properties and became one. That is why he measured everything as a whole. But I will not go deeper into that right now. This is about something else. He uses the same laws of physics she used, the same equations, the same math. But his answer says the spin was counterclockwise, the exact opposite of what she recorded. So whose reality is real? Who do you believe? Neither and both at the same time? Before this, scientists hoped all the quantum madness would disappear at our human scale. Sure, we might argue about probabilities, but the actual events are shared between us. Frauchiger and Renner proved otherwise. 2 people can look at the same event and walk away with 2 completely different, mathematically flawless, mutually exclusive realities. If even the facts belong to each person separately, then what exactly is a fact? Facts are real, but only locally, only inside your head. You're not seeing the world slightly differently from the person next to you. You are literally living in a different universe. And you are both right. But maybe this is all just insane games on paper, and in 2018, this nightmare stayed a dry formula on a blackboard. Not a chance. Just 2 years later, in 2020, physicists dragged this paradox out of theory and into an actual laboratory. And what they got there permanently broke. Something that scientists had spent centuries assuming was unbreakable. In 2020, a team led by Nora Tischler at Griffith University in Australia decided to test this quantum madness in practice. They took lasers and photons and turned a philosophical paradox into a real tabletop experiment. They called the principle local friendliness. The idea is simple. For our world to stay normal, physics needs to believe just 3 basic things. First, every event has a definite outcome. Second, all observers are equally valid. Third, nothing travels faster than light. Sounds like the most reasonable foundation for reality, does it not? Every working scientist relies on all 3 every single day. But can you guess what the instruments showed? They set it up like this. They took 2 photons that are linked to each other and sent one to the left and one to the right. On each side, there is a detector. The left detector measures its photon and gets a result. But then, they measure the same photon again in a different way. If the first result was a real fact, solid, objective, then the second measurement has to agree with it. Like if you photograph an apple and it is red, then you photograph it again and it cannot suddenly be green. But it was green, thousands of times in a row. The statistics were ironclad. The system broke, with mathematical precision so extreme that physicists' jaws hit the floor. The experiment proved that at least one of these 3 rules is a lie. Either something communicates faster than light, or some people are more real than others, or events simply do not have objective outcomes. And guess which one science is being forced to give up? The first one. Do you understand what that means? Absolute events no longer exist. We used to think that if a photon hit a detector, a bullet hit its target, a coin landed heads, it happened for everyone. Now physics says no. It happened exclusively for you. Your fact is your personal non-transferable property. All of science was built for centuries on the idea that an experiment can be repeated and a shared truth obtained. But at the very bottom of reality, there is no truth for everyone. And there is no cosmic Supreme Court where you can bring your version of events and have it declared the right one. Let us put this whole puzzle of horror together. Your brain hallucinates the picture from the inside. The outside has no properties until you look. The past did not exist until your observation in the present created it. And now it turns out that even your personal facts belong only to you. But wait. If your truth is only yours and mine is only mine, then there must be at least something shared. Some common rulebook. Some set of laws that works the same for everyone. And such a rulebook exists. Or rather it used to. In quantum physics, there is a thing called the wave function. It is basically the master equation that is supposed to describe everything about a particle. Where it is, how fast it is moving, what it will do next. Remember, everything is made of particles. Scientists have treated it for almost 100 years as the most fundamental description of reality. But in 2002, physicists Carlton Caves, Christopher Fuchs, and Rüdiger Schack looked at this equation and asked a very simple question. If Frauchiger-Renner proved that two observers get opposite facts, and local friendliness proved that absolute events do not exist, then the wave function cannot be describing the real world. If this formula was supposed to describe the real world, then it is like a map. One world, one map. Everyone who opens the map should see the same streets, the same buildings, the same distances. But we just proved that two people can open this map, and one sees a square building, and the other sees a rectangle. And both are right. So what kind of map shows different things to different people? Not a map of the world, a map of you. Your personal guess about what you will find around the next corner. We already said that essentially everything works from the observer, and your personal map works through your perception. They called this idea QBism. And it means the wave function is not a picture of reality. It is your private cheat sheet. It does not exist out there in the world. It exists exclusively inside your head. It is just your personal betting system for what will happen next based on your past experience. Do you see where this leads? When a physicist writes a complex equation for a particle, he is not describing the particle. He is describing his own level of knowledge. And when the famous wave function collapse happens during measurement, the real world does not change at all. You know what collapses? Your expectation. The particle does not care. It stayed the same. The only thing that changed was the information inside your brain. Sounds like the egomaniacal ravings of a lunatic turning the universe into a solo game. Most scientists thought the same. Okay, fine. Let us accept it. We are each locked in our own reality. No shared facts, no common rulebook. But at least things happen in order. First you wake up, then you open your eyes. First you strike a match, then it lights. At least cause and effect still work, right? Our entire lives and all of common sense are built on one steel rule. Cause first, effect second. You open the door before you walk through it. You wake up before you get out of bed. Every equation in science prays to this law. If event A causes event B, then A happened first. Remove that and the universe falls apart. But what if linear time is just a crutch your brain desperately generates to keep from going insane in the face of actual reality? In 2021, a team led by Philip Walter at the University of Vienna built a quantum optical circuit and sent a single photon through it. They applied two operations to that photon, call them A and B. In normal physics, either A happens before B or B happens before A. Like walking through a door, you either enter first or you exit first. There is no third option, right? The photon experienced A before B and B before A at the same time, not one or the other, both orders simultaneously. And this is not a thought experiment. The detectors produced a result that is physically impossible if events happened in any single sequence. They called it the quantum switch. Do you realize what they broke? They proved that at the base level of reality cause and effect, have no fixed order. A can come before B and B can come before A, and both are absolutely true at the same moment. If cause and effect can swap places, then the arrow of time from past to future is not a law. It is a filter inside your nervous system. Down at the bottom there is no sequence, no before and after, everything at once. But if time is broken and events happen in every direction simultaneously, then what is left? What about space? What about the room you're sitting in right now? What if the distance between you and the screen is nothing but a rendering error? Think about what everything in your life is built on. Your biography, your career, your relationships. One unbroken chain of cause and effect. You did this, so that happened, so you ended up here. But the quantum switch just blew that chain apart. At the base level, the universe does not care what came first. We massive objects made of trillions of particles are forced to see events one after another. But the machinery underneath runs all orders at once. Can you guess what physicists did with that knowledge? In 2019, a team at the University of Queensland proved that broken time is not a glitch. It is a resource. They use the absence of causal order to transmit information far more efficiently than anything possible in a world with normal linear time. Think about that. Stepping outside of chronology lets you do things the arrow of time forbids. The universe without cause and effect is not broken. It is running on cheat codes. How do you feel knowing that linear time might just be a built-in limiter inside your brain? So we have lost the properties of things. We have lost objective facts. We have lost the past. And now we have lost the order in which events happen. But there must be something solid left. You can clearly see the meters of space between you and the wall right now. If we cannot trust time, can we at least trust space? Physicist Raphael Sorkin is certain that we cannot. Imagine reaching your hand toward the screen and suddenly realizing there is physically nothing between your fingers and the glass. No air, no gap, no distance. You are suspended in absolute nowhere and your brain is just painting meters and centimeters to keep you functional. Since the 1980s, physicist Raphael Sorkin at the Perimeter Institute has been developing Causal Set Theory. The idea grew out of one catastrophic problem. Einstein said space is a smooth, continuous fabric. Zoom in as far as you want, and it stays smooth. Sounds reasonable until scientists tried to combine that with quantum mechanics. You know what happened? The equations exploded. Every calculation gave infinity. The two greatest theories in human history are incompatible, because one says the universe is smooth, and the other says everything is pixelated. Sorkin's solution. Space is not a fabric at all. It is a collection of isolated events, points. Between them there is no vacuum, no empty distance, no meters. There is only the bare fact that event A is connected to event B. The universe is simply a growing network of connections. Do you understand what that means for the room you are sitting in? The three-dimensional world around you is not a container. It is a pattern of connections that your brain renders as volume. The wall is over there not because 3 meters of physical emptiness separate you from it. The wall is over there because a chain of connections lined up in a way your brain interprets as distance. Remove the connections and there is no empty room left. There is no room. There is nothing. If space is just a rendering, a glitch in our perception, then what is the world actually made of? What generates this fake geometry? In 2013, a physicist at the Institute for Advanced Study found an answer that is still causing panic in the scientific community. And the answer exists in a place with no space and no time at all. To understand the scale of what happened in 2013, you need to know how physicists suffered before. Since the 1940s, the way scientists calculated particle collisions was through Feynman diagrams. Think of it as building a massive flowchart for every possible way 2 particles could bounce off each other. A simple collision between 2 particles could require hundreds of these diagrams, each with hundreds of terms. Months of calculation for one collision. It was absolute hell. In 2013, physicists Nima Arkani Hamed and Jaroslav Trnka took those hundreds of complex equations and threw them out the window. They found that all of it can be replaced by a single calculation. Just measure the volume of an abstract geometric shape. They called it the Amplituhedron. No particles flying through a void. No time, no space, just pure geometry giving you the exact same answer. Can you see what is terrifying about this? The Amplituhedron does not exist in our space or our time. It sits in an abstract mathematical dimension where there are no clocks, no coordinates, no millimeters. Nothing from our familiar world is there. But it is precisely from the shape of this object that all the physics we observe is born. The thing that dictates how particles behave lives in a place where particles do not exist. So what is our universe compared to it? A shadow, a projection. The three-dimensional streets you walk on and the time that is aging your body are not the foundation of reality. They are what the Amplituhedron looks like when it is projected down to the scale of our perception. Space and time are not the arena where life happens. They are the user interface, icons on a desktop hiding the actual code underneath. So we have lost properties, we have lost facts, we have lost time and space. Our world turned out to be a graphical shell stretched over a void. But if all of that is fake, then what is left to hold on to? There must be one unbreakable foundation. What about pure cold mathematics? Numbers and equations will not betray us even if the world crumbles into pixels. Right. Ever had that feeling where you know you are absolutely right, but you cannot prove it? The argument is clear in your head, but the words refuse to line up. What if that is not a communication problem? What if the universe itself forbids certain truths from ever being proven, even when they are staring you in the face? In 1931, a 25-year-old named Kurt Gödel took the foundation of his own science and destroyed it. At the time, every great mind in mathematics was trying to prove that math was a perfect closed machine, a system of rules that could explain everything and verify itself without a single contradiction. The ultimate tool to crack reality. You know what Gödel did? He proved that this is impossible. Period. His incompleteness theorem says that if a system of rules is even slightly more complex than basic arithmetic, there will always be facts inside it that are 100% true but cannot be proven within the system. Not because we have not found the proof yet. Not because we are not smart enough. The proof does not exist. The system was assembled with holes by design. There will always be truths that logic can see but never reach. Think this is abstract number games. It is the foundation under everything. Engineering, physics, the economy. Any useful system of rules obeys a cruel law. If it is logical, it has blind spots. If you try to patch every hole, it starts spitting out contradictions. You cannot have both. That is not a guess. That is a mathematical verdict. So our greatest tool for understanding the world is structurally crippled. Mathematics does not describe all of reality. It describes only the piece its short arms can reach, and there will always be a piece it cannot. But the next question was practical. Fine, if we cannot prove everything on paper, maybe we can at least compute everything mechanically. Build a perfect machine. Give it infinite time. Let it solve any problem. You believe a powerful enough computer can calculate anything eventually, do you not? In 1936, Alan Turing tested that. At 23, Alan Turing was looking for a universal procedure. A perfect algorithm where you feed in any question, press the button, and get a guaranteed answer. Does such a thing exist? To find out, he invented an imaginary machine, an infinite tape with symbols, and a head that reads them step by step. Recognize it. That is the theoretical blueprint of every computer on Earth. Your phone, the servers running your apps. All of them are versions of Turing's tape. And you know what he proved about it first. This perfect machine is doomed to fail from the start. They called it the halting problem. Can an algorithm look at another program and predict whether it will eventually finish or freeze forever? Like watching that loading wheel spin on your screen. Is it thinking or is it stuck? Seems like you just need smarter code or a faster processor. Turing proved mathematically that no such algorithm can exist, not because it is hard, because it is logically impossible, and undecidability does not stay in one corner. It spreads. The moment you find one unsolvable problem, it spawns hundreds more. How will this code behave? Will this equation resolve? Entire families of questions that no supercomputer can answer, even given the lifetime of the universe. Gödel showed math has truths it cannot prove. Turing proved computation has problems it cannot solve. These limits hit the same point. Our ability to understand reality has a hard, concrete ceiling. In 1975, mathematician Gregory Chaitin decided to measure how high that ceiling is. He found a specific number that defines the boundary of all possible knowledge, but the number itself is something no mind will ever see. In 1975, Gregory Chaitin defined a number called omega. The idea is absurdly simple. Take every possible computer program. What is the probability that a randomly chosen one will finish its job rather than loop forever? That probability is omega, a specific fraction between 0 and 1. It is precisely defined. It absolutely exists. And you know what the catch is. It is fundamentally impossible to compute. Every single digit after the decimal point is pure mathematically perfect chaos. No patterns, no formulas, no shortcuts, no amount of information will tell you the next digit. How do you feel about a value that is perfectly real and permanently unknowable? And this is not a puzzle built to be difficult. Inside omega is the answer to Turing's halting problem for every program ever written. Know omega, and you solve every problem the best algorithms in history have given up on. It is the master key to every locked door in science. But the universe hung that key just out of reach. It exists. You can prove it exists. You can never touch it. Chaitin proved that the dead ends Gödel and Turing found are not accidents. Absolute chaos is stitched into mathematics the same way emptiness is stitched into quantum physics. Our most reliable science is built on unknowability from the ground up. We desperately hoped equations would not betray us even if space and time were illusions. But Gödel said logic has holes. Turing proved computation hits a wall. And Chaitin measured the wall and found it is infinite. If mathematics cannot fully describe this world, then what is actually happening around you right now? What process is generating reality this very second if the familiar laws of logic do not apply? We are used to thinking in simple terms. Cannot see something. Get a brighter flashlight. Build a bigger telescope. A more powerful collider. A faster computer. Everything hidden will be revealed. Omega crushed that illusion. The darkness beyond our understanding does not come from weak instruments. It is a built-in property of the universe. You could create an infinitely powerful beam of logic, and it would never pierce it. The nature of what is out there is fundamentally incompatible with comprehension. You thought we were assembling a puzzle of the universe piece by piece, that one day we would see the whole picture. We are not. We are crawling with a ruler across a tiny island of logic, surrounded on all sides by an infinite ocean of incomputable chaos. And no matter how precisely we map our shore, that ocean does not shrink by a millimeter. Boundless, permanent, indifferent to our progress. What exactly is out there in that black water? If the universe contains processes no formula can digest, then what are they? Random noise, or a monstrous structure our brains have no receptors for? Nobody knows. And Chaitin guarantees nobody ever will. Not because we lack time or intelligence, because the answer exists in a form that cannot be grasped or spoken. So mathematics has a ceiling. Computation has a wall. The unknowable is permanent. But what if math was never describing the universe in the first place? What if the universe is not something that gets described at all? What if it is a machine? And what if that machine is running right now using you as a line of code? There are scientists who say this literally. Konrad Zuse, who built one of the first programmable computers, spent the rest of his career arguing that the universe is one. Edward Fredkin at MIT, Stephen Wolfram. Their claim is not a metaphor. When a rock falls off a cliff, it is not obeying a law of gravity. The falling itself is the computation of the trajectory. The rock does not know it is computing. It does not need to. The fall is the calculation. They call it pancomputationalism. The laws of physics are the code. The state of the universe is the data. The passage of time is the step-by-step execution of instructions. And in this framework, there is no difference between hardware and software. The chemical bonds keeping your body together right now are continuous computations. The electrical impulses in your brain are not carriers of thought. Your memories and fears are raw information being processed by the medium they travel through. You are simultaneously the program and the machine running it. And here is where those dead ends of logic hit their target. If reality is a program, then the limits Gödel and Turing found are not weaknesses of human thinking. They are hardware limitations of the universe itself. The universe cannot predict its own future. It is packed with unsolvable problems hanging in its memory, consuming resources. Any programmer knows what happens when a system is overloaded with unresolvable contradictions. It buckles. But what does that look like when the system is a reality itself? What does a crash look like when the computer is the universe? When a computer tries to process something beyond its capacity, the result is an overflow. The system encounters a value it was not built to hold, and everything stops making sense. In the universe, the equivalent has a name, a singularity. A black hole forms when enough mass collapses into a small enough volume that the equations of general relativity return infinity as the answer. Infinite density, infinite curvature. But infinity is not a physical result. It is a sign the calculation broke. The same way dividing by zero crashes a program, a singularity crashes the math. The equations stop giving meaningful output. If the universe is a computation, then a black hole is not just extreme gravity. It is a region where the computation failed. A point where the program tried to calculate something beyond its capacity and produced nonsense. And we do not have one of these. We have billions. The Milky Way alone contains roughly 100 million of them, and one at the center that weighs 4 million times more than the Sun. So, the computation that produces reality is failing in 100 million places in our galaxy alone. And at each of those crash points, something happens to the information that falls in. It does not come back out, which raises a question that has been shredding physics apart for almost 50 years. What happens to information when it crosses that boundary? Because in 1961, a physicist at IBM proved that information is not what we thought it was. Rolf Landauer at IBM proved something in 1961 that permanently changed the relationship between information and physics. He showed that erasing a single bit of information releases a measurable amount of heat. Not as a side effect, as a law. Destroying information is a physical event with real energy. Think about that. A bit of information is not abstract. It is not just something on a screen or in a textbook. It has thermodynamic consequences. It produces heat when destroyed. It has entropy. If you erase it, the universe physically responds. Information is not like matter. It is in the same category as matter. And this is not theory. In 2012, a team in Paris measured the heat produced by erasing one single bit, stored in a tiny particle. The amount matched Landauer's prediction exactly. Information is physical, measurably, reproducibly, proven. So if information is physical, then it should follow physical laws. And the most important law it should follow is conservation. Energy is conserved. You cannot create it or destroy it. In quantum mechanics, information is supposed to work the same way. Scramble it, encode it, but you cannot destroy it. Whatever goes in must come out somewhere. And this is where black holes become a crisis, because information falls into a black hole, and as far as anyone can tell, it never comes back. In 1975, Stephen Hawking published a calculation showing that black holes are not permanent. They radiate energy, slowly, over enormous stretches of time, they evaporate. This was a breakthrough because it connected gravity to quantum mechanics for the first time. But it came with a problem that Hawking himself spotted immediately. The radiation coming out of a black hole is random. Thermal noise. It contains no trace of what fell in. A book falls in. A chair falls in. The radiation that comes out is identical in both cases. The information about what went in is gone. This is called the black hole information paradox, and it has been unresolved for 50 years. If the information is truly erased, then quantum mechanics is wrong because quantum mechanics says information is always conserved. If the information somehow survives in the radiation, then we need a mechanism nobody has found. If it is stored somewhere inside the black hole or in some structure we cannot detect, then we need physics that does not exist yet. 3 options. Every one of them breaks something fundamental. 50 years and the field has not agreed on which one to break. Hawking changed his mind twice. First, information is lost, then it is preserved. Then he was not sure. So information is physical, it has energy, it should be conserved. And we have 100 million objects in our galaxy that may be destroying it. If the universe is a computation, then information is the substance it computes with. And something is eating the substance. Unless the rules of computation are different from what we assumed. In 2014, David Deutsch proposed that they are. David Deutsch is one of the founders of quantum computing. In 2014, he and physicist Chiara Marletto proposed something called constructor theory. The argument starts with a simple question. What if physics has been asking the wrong question this entire time? Traditional physics asks what happens. You set up initial conditions and calculate what state the system ends up in. Constructor theory asks a different question. What transformations are possible and what transformations are impossible? Not what does happen, what can happen. The difference sounds minor, but it changes everything. Traditional physics tracks particles through space and time. But we already know space and time may not be real. Constructor theory does not need them. It works at a deeper level. It defines the laws of physics as rules about which transformations of information can occur and which cannot. Think of it like this. Instead of describing every move in a chess game, you describe which moves are legal and which are illegal. You do not care about any specific game. You care about the rules. And from the rules alone, you can figure out everything that is possible. In this framework, information is not just physical. It is more fundamental than matter and energy. Matter and energy are what information looks like when it undergoes certain transformations, which reframes the black hole crisis entirely. The question is not whether information survives inside a black hole. The question is what class of transformation a black hole represents. And constructor theory says something about life that no other framework says. Something that changes what it means to exist in this universe. In traditional physics, life is an accident. The right molecules happen to bump into each other and self-replication emerged by blind chance. In constructor theory, life is not an accident. Life is a transformation that the laws permit. And if a transformation is possible and conditions arise, then it is not a matter of luck. It is a matter of time. Think about gravity. You do not ask why a rock falls. The rules say mass curves space. Rocks fall, period. Constructor theory says the same about life. You do not need to explain why living systems appeared. The rules permit self-replicating information transformations. So they appear. Not by luck, by structure. So here is what the last few acts have taken away. Gödel proved math cannot reach all truths. Turing proved computation cannot solve all problems. Chaitin proved the unknowable is infinite and permanent. The universe may be a computation crashing in 100 million places in our galaxy. Information is physical and something may be erasing it. And the deepest description we can give is not about objects in space, but about which transformations of information are allowed. Everything has been stripped. The brain, the properties, the facts, space, time, math, matter, and yet here you are, still processing, still asking what is left. there is one thing left. The thing that has been doing the watching this whole time. And now we find out what it is. For most of the history of science, consciousness was not a question. It was a side effect. Neurons fire, chemicals flow, and somewhere in all that machinery, something lights up and there is an experience. Nobody could explain how. Nobody could even define what lights up. It was treated the way weather was treated before we understood the atmosphere. It happens. We see it. We do not understand the mechanism. In 2004, neuroscientist Giulio Tononi at the University of Wisconsin decided that was not acceptable. He proposed integrated information theory, IIT, and its central claim is that consciousness is not a byproduct of brain activity. It is a measurable physical quantity. He gave it a symbol, phi, and a definition. Phi is the degree to which information in a system is connected above and beyond the information in its separate parts. Here is what that means. A simple light sensor responds to brightness, one bit of information, bright or dark. But that bit exists in isolation. It connects to nothing else. Its phi is effectively zero. Now take your brain. 100 billion neurons each wired to thousands of others. Your visual system is linked to your memory, which is linked to your emotions, which are linked to your sense of self. Everything connects to everything. The whole is vastly more than the parts. Phi is enormous, and here is what makes this different from every other attempt to explain consciousness. Phi is a number. It can in principle be calculated. Consciousness is not a hand-waving mystery. It is a quantity with a value. And the theory says anything with a phi above zero has some degree of experience. Not human experience, not complex experience, but experience. Which raises the question, how far down does that go? If phi is the measure of consciousness and anything with integrated information has some phi, then consciousness is not a switch that flips on at a certain level of complexity. It is a dial. And the dial starts at zero and goes up, and there is no point where you can draw a line and say, below this, nothing, and above this experience. A thermostat has a tiny amount of integrated information. Its phi is almost zero, but not zero. A worm has more. A dog has more than a worm. A human brain with its 100 trillion connections has a phi so large we cannot currently compute it. But none of these are different in kind. They are different in degree. The thermostat and the human are on the same scale. One near the bottom, one near the top, but one scale. And this does something strange to the idea of human specialness. We did not acquire consciousness at some point in evolution. We did not cross a magic line that separated dead matter from living experience. We are a point on a continuum that stretches in both directions. Below us, there are simpler systems with less integration. Above us, there could be systems with more integration and more experience that we cannot recognize, because we do not know what experience looks like at that scale. So consciousness is not a brain thing, it is an information thing. Wherever information is integrated, there is something it is like to be that system. And if that is true, then where exactly does consciousness live inside the brain? Where is phi highest? Neuroscience has been looking for 50 years. What it found is that there is no single seat. You're experiencing a unified scene right now. Colors, shapes, the sound of your own breathing, the meaning of these words, the sense of being someone who is taking all of this in. It feels like one seamless thing assembled in one place, but the brain does not work that way. Shape is processed in one area of the visual cortex, color in another, motion in a third. Sound is in the temporal lobe, touch in the somatosensory cortex, memory in the hippocampus, emotion in the amygdala, language in two separate regions. None of these share a format. None of them send their outputs to a central screen. There is no theater inside your skull. There is no room where the picture comes together. This is called the binding problem, and it has been open since the 1990s. How does the brain take dozens of separate streams running in different regions at different speeds, in different formats, and produce the unified experience you're having right now. The color of the wall is processed separately from its shape, and both are processed separately from the sound in the room. And yet, you experience one room, not a collection of fragments. After 30 years of looking, nobody knows how. We know which regions correlate with which parts of experience. We can map those correlations in extraordinary detail, but correlation is not explanation. Saying the visual cortex is active when you see something does not explain why seeing feels like anything at all. So consciousness cannot be localized. It has no address. The experience is unified, but the processing is scattered. Something binds it together, and that something has no known location, which led one of the most respected physicists on the planet to propose that the answer is not in the neurons. It is inside them. Every attempt to find the source of consciousness in the brain follows the same pattern. A new scanning technology arrives. Researchers watch brains during conscious experience. They find correlations. This region lights up when you see red. That one activates when you feel fear. The map gets more detailed every year. And every year the fundamental question remains untouched. Why does any of this feel like anything? A computer processes information, takes input, produces output. But there is nothing it is like to be a computer. Processing happens, and no experience accompanies it. A brain also processes information. Input in, output out. But there is something it is like to be a brain. There is a felt quality to the red and the fear and the sound of a voice. Where does that quality come from? David Chalmers called this the hard problem in 1995. The name stuck because 3 decades later, it is still hard. The easy problems of consciousness are about function. How does the brain sort stimuli? How does it integrate data? How does it control behavior? Those are engineering questions, and we are making progress. The hard problem is about experience itself. Why is there something it is like to be you? And no functional explanation touches it. Something else is going on. And the most radical proposal for what that something is came from a Nobel Prize winner who thinks the answer is quantum. In 1989, Roger Penrose published a book arguing that consciousness cannot be produced by classical computation. His reasoning starts with Gödel. If the brain were a standard computer, it would be subject to the incompleteness theorem. There would be truths it could see but never prove. But humans can see Gödel sentences and recognize that they are true. We can step outside the system in a way no algorithm can. Therefore, the brain is not running an algorithm. It is doing something else entirely. Penrose proposed that the something else is quantum, that the brain performs a type of quantum computation that is not subject to Gödel's and Turing's limits. And he teamed up with Stuart Hameroff, an anesthesiologist who had been studying tiny structures inside neurons called microtubules. These are protein tubes about 25 nanometers wide that form the skeleton of the cell. Hameroff had argued for years that they were not just structural supports, they were processors. Together they proposed orchestrated objective reduction, Orch-OR. The idea works like this. Quantum superpositions form inside microtubules. These are held in a stable state by the structure of the proteins. When the superposition reaches a critical mass, it collapses. Not because somebody measured it, because gravity itself forces the collapse. And each collapse is a moment of conscious experience. So consciousness in this model is not neurons firing. It is quantum events inside structures within neurons, at a scale we can barely measure. The mainstream reaction was skepticism. The brain is too warm and too wet. Quantum coherence should collapse in femtoseconds. No way quantum effects survive long enough to matter. That was the consensus for 20 years. Then the experiments arrived. In 2014, researchers discovered that general anesthesia, the process that switches consciousness off, acts specifically on microtubules, not on synapses, not on the chemical messengers between neurons. on the exact structures Hameroff had been pointing to for decades. The drugs that erase your experience target precisely the structures Orch-OR says produce experience. That is not proof. But it is exactly what the theory predicted, and the critics did not. In 2022, a team at Trinity College Dublin detected quantum-level signals in microtubules from living neurons at room temperature. This was supposed to be impossible. The standard objection had always been that biology is too warm for quantum effects. Quantum coherence needs temperatures near absolute zero. Warm cells should destroy it instantly. And yet the signal was there. The criticism is still strong. Detecting a quantum signal in a test tube is not the same as demonstrating quantum computation in a living brain. The gap is enormous, and Penrose's claim that gravity causes the collapse has no experimental confirmation. But the theory has not been destroyed either. It hangs in a space science finds deeply uncomfortable, not wrong enough to throw away, not proven enough to accept. And the reason it refuses to go away is that nothing else explains the binding problem. Nothing else gives a mechanism for how scattered processing becomes unified experience. Classical models give you correlations. Orch-OR gives you a mechanism, flawed, speculative, untested in full, but a mechanism. And right now, it is the only one. So consciousness may be quantum, produced by events at a scale we can barely reach. And if that is true, then consciousness is not something the brain generates as a bonus feature. It is woven into physics itself, which means the question is not whether the brain creates consciousness. The question is whether the universe does. There is a question that sounds simple and is not. Why does the world look definite? We have spent most of this video establishing that at the quantum level, nothing is definite. Properties do not exist. Facts are personal. Time has no order. Yet you look at a wall and it is there, solid, one color, in one place, not blurred across every possible version of itself. Something takes the quantum chaos and makes it look classical. What? In 2003, Wojciech Zurek at Los Alamos National Laboratory proposed an answer. He called it quantum Darwinism. The idea is that when a quantum system interacts with its environment, the environment does not just passively absorb information, it selects. The quantum states that are best at copying themselves into the surroundings survive. The ones that cannot copy get destroyed by decoherence. Zurek called the survivors pointer states. Think of it like this. Millions of possible quantum states compete. Only the ones that can stamp copies of themselves into the photons bouncing off objects, into the air molecules, into your retina, make it through. Everything else gets erased. You do not see reality. You see the winners of a selection process. And you mistake survival for truth. This means objectivity is not a feature of the universe. It is a result of filtering. The things we all agree on, the things that feel most real, are simply the states that were best at propagating copies. Objectivity is a replicator. And like any replicator, it does not need to be true. It needs to be good at copying itself. So who is doing the selecting? What is on the receiving end? What collapses the blur into a picture? The observer. If the classical world exists because certain quantum states copy themselves into the environment, and if that copying requires something on the receiving end to accept the copies, then without a receiver, there is no selection. Without selection, there are no pointer states. Without pointer states, there is no definite world. Remove the observer and the world does not become fuzzy. It stops being a world. This is not philosophy. Zurek wrote the math. The pointer states emerge from the equations of decoherence, and those equations require three things: a system, an environment, and an interaction between them. The environment alone does not produce a definite reality. The system alone does not either. It is the relationship between the system and what observes it that produces the solid world you see. And this connects directly to Kochen-Specker from the beginning. Properties do not exist before measurement. Zurek explains why. Properties are not revealed by measurement, they are selected by measurement. The act of observing filters quantum possibilities down to the ones that can survive being copied into the observer's environment. The ones that survive are what we call properties. The ones that do not survive never existed. The world is real because someone is looking at it. Not real in the way we assumed. Not solid and waiting to be discovered. Real the way a signal is real. It exists at the point of reception. No receiver, no signal. No observer, no world. We have now arrived at the point where everything is stripped, except the observer. The brain hallucinates. The outside has no properties. Facts are personal. Space and time are interfaces. Math has a ceiling. Information is physical and something is erasing it. And the definite world exists only because something is watching it. So what is the observer? What is this thing that every layer keeps pointing back to? One philosopher thinks he knows. And his answer is that the observer is the only thing that ever existed. Bernardo Kastrup holds a PhD in computer engineering and a PhD in philosophy. For a decade, he has been building the case that modern science has it backwards. We assume matter is fundamental and consciousness emerges from it somehow. Kastrup says the opposite. Consciousness is fundamental. Matter is what consciousness looks like from the outside. This is not New Age hand-waving. He points to everything in this video and says, the pattern is obvious. Properties do not exist without measurement. Facts are personal. The classical world requires an observer. The binding problem has no physical solution. IIT says consciousness is measurable. Quantum Darwinism says the observer creates definiteness. Every result we have covered points in the same direction. The observer is not a side effect. The observer is the source. In Kastrup's framework, the universe is not matter that somehow produces minds. It is one mind that produces what looks like matter. Physical reality is the external appearance of mental processes. The brain does not generate consciousness. The brain is what consciousness looks like when viewed from the outside. Think of a whirlpool. The whirlpool is not separate from the water. It is a pattern in the water. Your body and brain are not separate from consciousness. They are a pattern in consciousness. But this raises the obvious problem that should have ended the theory immediately. If the universe is one mind, then why are there billions of us? Why can I not feel what you feel? Why does your experience feel completely separate from mine? If it is all one consciousness, why does it not feel like one? Kastrup's answer is the most disturbing part of the entire theory. Dissociative Identity Disorder. One body, one brain, multiple identities. Each one has its own memories, its own preferences, its own emotional patterns, its own sense of being a separate person. And they do not know about each other. Identity A has no access to the memories of Identity B. They share a body, but they do not share an experience. From the inside, each one feels like the only one. Kastrup says this is what the universe is doing. One consciousness, dissociated into billions of fragments. Each fragment is a living being. Each one experiences itself as separate and alone. And the dissociation is so complete that no fragment can access the experience of any other. You cannot feel what I feel. I cannot see what you see. Not because we are different objects made of different matter, because we are separate fragments of the same mind. And the evidence from dissociative disorders is specific. Brain scans show that different identities in the same body have measurably different neural patterns, different visual sharpness, different responses to the same stimuli. These are not moods or performances. They are neurologically distinct states in one brain. The walls between identities are not just psychological, they are structural. They show up on instruments. Kastrup says the same mechanism operates at the scale of the universe, the fundamental consciousness fragments. Each fragment becomes a living being with its own private experience, unable to access the whole. We are the fragments. So deep inside our own dissociation that we built an entire civilization on the assumption that we are separate objects in a material world, not because of a conspiracy, because the dissociation is that complete, and now everything starts fitting together. QBism says reality is a single-player game. Kastrup says it is a single-player game because each player is a dissociated fragment playing alone. Kochen-Specker says properties need an observer. Kastrup says, of course, because properties are experiences, and experiences require a subject. No subject, no property. Frauchiger and Renner proved two observers get contradictory facts. Kastrup says that is what happens when two fragments of the same mind process the same thing through different dissociative boundaries. The facts differ because the fragments differ. Local friendliness proved absolute events do not exist. Kastrup says events are experiences, and experiences are always first person. There is no third person event. There never was. The binding problem asks how scattered processing becomes unified experience. If consciousness is fundamental, the question dissolves. Experience does not need to be assembled from parts. It is the parts that are carved out of experience. Integration is not the mystery. Dissociation is. And clinical neuroscience shows us exactly how that works. 19 experiments and theorems, produced by people who were not trying to support each other's work. And they all point at the same thing. The observer is not a passenger, not a product. It is the only thing that was never removed because it cannot be. We spent the entire video stripping reality down to nothing. And the nothing turned out to be the thing doing the stripping. But you might say this is just philosophy, beautiful ideas that cannot be tested. How do we know consciousness can actually split and merge? How do we know one awareness can become two? In 1962, a surgeon took a knife to a living brain and answered that question permanently. In 1962, neurosurgeons Joseph Bogan and Philip Vogel performed the first complete corpus callosotomy. They took a patient with severe epilepsy and cut the corpus callosum, the thick bundle of nerve fibers connecting the left and right hemispheres. 200 million connections severed in one operation. The seizures stopped. The patient walked out and seemed fine. But neuroscientist Roger Sperry and his student Michael Gazzaniga began testing what had actually happened inside that skull. And what they found won Sperry a Nobel Prize. They showed the patient an image only to his left eye, which feeds into the right hemisphere. The patient could not name what he saw. Why? Because language lives in the left hemisphere and the bridge was cut. But when they asked the patient to reach behind a curtain and pick the matching object with his left hand, which is controlled by the right hemisphere, he grabbed the correct one instantly. One brain, two separate minds, one that could speak but did not see the picture, one that saw the picture but could not speak. It got stranger. In some tests, the left hand would reach for one object, and the right hand would slap it away and grab a different one. Two intentions, two preferences, two wills operating in the same skull, fighting over the same body. Gazzaniga called it the interpreter because the left hemisphere would invent explanations for what the right hemisphere was doing. Not real explanations, stories, fictions. The speaking half of the brain was confabulating reasons for actions it had no access to. Do you understand what this means for everything Kastrup proposed? One consciousness became two by cutting a physical connection. The dissociation is not metaphorical. It is surgical. You can take a knife and split awareness in half, and each half will insist it is the whole person. If that works inside one skull, what stops it from working at the scale of the universe? One mind, dissociated, each fragment convinced it is alone. And now here's a question that makes it even worse. If consciousness can split, then what about the other direction? What if it is not just brains that are conscious? What if it goes all the way down? Everything we have found so far keeps pointing at the observer. Properties need one. Facts require one. The classical world assembles around one. Tononi says consciousness is measurable, and anything with integrated information has some. Kastrup says consciousness is fundamental, and everything is a fragment of it. But there is a position even more extreme than Kastrup's, and a growing number of physicists and philosophers are taking it seriously. It is called Panpsychism, and its claim is simple. Consciousness is not something that emerged at some point in evolution. It did not suddenly switch on when brains got complex enough. Consciousness is a basic property of matter the same way mass and charge are basic properties. An electron has mass, it has charge, and it has some minimal form of experience. This sounds insane until you look at the alternative. If consciousness is not fundamental, then at some point in the chain from atoms to molecules to cells to brains, something that had zero experience suddenly produced experience. Where is that line? Which atom is the one that tips the scale? Nobody can find it because it does not exist. The hard problem of consciousness is hard precisely because there is no mechanism that turns non-experience into experience. Panpsychism dissolves the problem by saying the turn never happened. Experience was always there. It just gets more complex as systems get more integrated. And remember Tononi's phi. A thermostat has a phi that is almost zero, but not zero. Integrated information exists at every scale. If phi is the measure of consciousness and phi is never truly zero, then consciousness is everywhere. Not human consciousness, not thoughts or feelings, but something. A flicker, a proto-experience at the level of every interaction between particles. So the universe is not dead matter that accidentally produced one species that can think. The universe is thinking, at every level, in every atom. And what we call our consciousness is just one particularly complex fold in a fabric that has been aware all along. But if the observer is everywhere and consciousness is woven into everything, then what exactly does the observer do to reality? In 1999, a group of physicists set up an experiment that answers that in the most disturbing way possible. In 1999, Yoon Ho Kim and a team at the University of Maryland built an experiment called the Delayed Choice Quantum Eraser. And what it demonstrated should be illegal in a sane universe. Here is how it works. They fire a photon at a barrier with two slits. Normally when a photon passes through two slits, it creates an interference pattern on the detector behind. Waves overlapping. This means the photon went through both slits at the same time. But if you put a detector at the slits to find out which one the photon actually went through, the interference pattern vanishes. The photon behaves like a particle, goes through one slit, normal quantum weirdness so far. Here is where it gets terrifying. In this experiment, each photon is paired with a twin. The twin is sent to a completely separate detector far away. The original photon hits the screen. No interference pattern. It went through one slit. Fact recorded. History written. But then the experimenters do something to the twin. They erase the information about which slit the original photon went through. They do this after the original has already hit the screen, after the fact is supposedly established. And when they erase that information from the twin, the interference pattern reappears on the original photon's detector. The photon that already hit the screen retroactively went through both slits. A decision made in the present changed what happened in the past. Not in theory. On a detector. Recorded. Published. Replicated. Let that sink in. The original photon already arrived. The result was already recorded. And then a measurement on a completely separate particle in a completely different location changed what the first particle did before it arrived. The past is not fixed. The past is being edited right now by what you choose to observe in the present. And if you think that is just photons doing weird photon things, consider this. You are made of particles that obey these exact same rules. Every observation you make right now is not just reading history. It is writing it. The question is, how far back does the writing go? One physicist spent his entire career on that question, and his answer was that it goes all the way back. John Archibald Wheeler was not a fringe thinker. He named the black hole, he worked on the Manhattan Project, he was Richard Feynman's doctoral advisor, and in the last decades of his life he became convinced of something that most of his colleagues thought was crazy. He believed the universe does not exist until it is observed. Wheeler proposed a thought experiment called the Delayed Choice Experiment. Imagine light from a quasar billions of light years away. The light has been traveling for billions of years. On its way to Earth, it passes a massive galaxy that bends its path through gravitational lensing. The photon can go left around the galaxy or right. In quantum mechanics, it does both until something forces a choice. Now here is Wheeler's point. We set up our telescope today. We choose how to measure that photon today. And our choice today determines which path the photon took billions of years ago. We are not observing ancient history. We are creating it, right now, with our instruments. Wheeler compressed this into 3 words. It from bit. Every physical thing, every it, derives its existence from observations, from bits of information. The universe is not a machine that runs and then gets observed. The universe is built by observation. Each measurement is an act of creation. Each question we ask, reality forces reality to give an answer that did not exist before the question was asked. And this is not just Wheeler's philosophy. It is exactly what Kochen-Specker proved. Properties do not exist before measurement. It is what the delayed choice eraser confirmed. The past is written by the present. It is what quantum Darwinism describes. The classical world exists because observations select it into existence. Wheeler just said what all the experiments were already showing. The universe is participatory. It does not happen without participants. So the observer creates properties. The observer creates facts. The observer edits the past. The observer selects which quantum states become real. And now the question becomes, what is the universe that the observer is creating? What is this thing we are projecting into existence? What shape does it actually have? In 1993, 2 physicists answered that, and the answer is that reality has far fewer dimensions than you think. In 1993, Gerard 't Hooft and Leonard Susskind independently proposed something called the holographic principle. The idea grew out of a simple calculation about black holes. When physicists computed the maximum amount of information a black hole can contain, they expected the answer to scale with volume. A bigger black hole, more space inside, more information. That is how storage works. A bigger hard drive holds more data. But the math said something different. The maximum information scales with surface area, not volume. The amount of data a region of space can hold is determined not by how big it is on the inside, but by the area of its boundary. Like discovering that a warehouse can hold exactly as much as you can write on its walls. The inside is irrelevant, everything is on the surface. 't Hooft and Susskind realized this is not just about black holes, it is about the universe. If the maximum information in any volume of space is encoded on its boundary, then the entire 3-dimensional world you experience could be a projection from a 2-dimensional surface. Not metaphorically, mathematically. The way a hologram on a credit card encodes a 3D image on a 2D surface. You see depth, you see volume, but the actual information lives on a flat plane. In 1997, Juan Maldacena at Harvard published a paper that made this concrete. He proved mathematically that a specific 5-dimensional universe with gravity is exactly equivalent to a 4-dimensional universe without gravity on its boundary. Every event inside has a perfect translation on the surface. The 2 descriptions are identical. The inside is not more real than the outside. They are 2 ways of reading the same data. And there is a limit to how small the pixels can get. It is called the Planck length. About 10 to the minus 35 meters. Below that distance, the concept of space stops making sense. The equations give nonsense, which means space has a resolution. It is not infinitely smooth. It is granular, pixelated. Like a screen, you are standing too close to notice the dots. So the 3-dimensional room you are sitting in may be a holographic projection from a surface with a finite pixel size. You are not inside space. You are being projected into what looks like space. But if space is a projection and the holographic principle links it all to information on a boundary, then what holds the projection together? What connects one pixel to the next? In 2013, 2 physicists found the terrifying answer. The glue holding space together is the same thing that makes quantum mechanics so strange. In 2013, Juan Maldacena and Leonard Susskind published a paper with one of the shortest titles in physics, ER equals EPR. 2 letters equals 2 letters, and it may be the most important equation since Einstein's. ER stands for Einstein-Rosen bridge, a wormhole, a tunnel connecting 2 distant points in space. EPR stands for Einstein-Podolsky-Rosen, quantum entanglement, 2 particles linked so that measuring one instantly affects the other no matter the distance. These were discovered in the 1930s as completely separate phenomena. Wormholes are about gravity and the shape of space. Entanglement is about quantum mechanics and information. They were studied by different people in different fields for 80 years. Maldacena and Susskind proved they are the same thing. Every pair of entangled particles is connected by a tiny wormhole, and every wormhole is a manifestation of entanglement. Gravity and quantum mechanics are not 2 separate forces awkwardly coexisting. They are 2 descriptions of the same underlying connection. And here is what that means for space. If entanglement equals wormholes, and wormholes are what connect points in space, then entanglement is what holds space together. Space is not a container that particles sit inside. Space is woven out of quantum entanglement between particles. The distance between you and the wall exists because particles between you and the wall are entangled in a specific pattern. Break the entanglement, and the space between those points tears apart, literally, not metaphorically. The geometry rips. In 2016, a team at Caltech ran simulations showing exactly this. When you remove entanglement from a region, the spatial geometry of that region disconnects. Space is stitched together by quantum information. And when the stitching comes undone, space comes undone with it. So everything we have been through arrives at the same point. The observer creates properties. The observer writes the past. Consciousness is fundamental. Space is a holographic projection. And the fabric of that projection is held together by quantum entanglement, which is the same thing as the connections between points in space. Information is not something that lives inside the universe. Information is what the universe is made of. Pull on any thread and you find the same thing underneath. The observer, the information, the connection between them. We went looking for the foundation of reality. We dug through the brain, through quantum mechanics, through space and time and mathematics and information. At the bottom, there was no foundation. There was a mirror. And in the mirror was the thing that had been looking the entire time. So here is everything we have lost. The brain does not show you the world. It builds a model and shows you the model, and the model is wrong in ways you will never detect from inside. The material the model is built from has no properties until something asks. The properties that appear belong to nothing and attach to no one. The past was not there until the present created it. And the present can reach back and rewrite what the past was. The facts you have are not the facts someone else has, and there is no place to compare. Cause and effect have no fixed order. Space is a holographic projection stitched together by entanglement. Time is a filter your nervous system generates. Mathematics has truths it cannot reach. Computation has problems it cannot solve. The unknowable is not a gap, but a permanent load-bearing wall. Information is physical, and something may be erasing it. The classical world that feels so solid exists only because something is watching. And consciousness is not a product of the brain. It is the fabric everything else is woven from. We removed layer after layer. The brain, the properties, the facts, space and time, mathematics, matter, information, and at the bottom of all of it was the one thing we could not remove: the observer. The thing that was doing the looking. The thing that noticed each layer being pulled away. The thing that right now is processing these words and experiencing something while it does. That thing is you, not your body. Your body is a pattern in something deeper. Not your brain. Your brain is a filter, not a generator. Not your name or your job or your history. Those are contents of experience, not the experiencer. You. The thing that is aware right now. The thing that has been aware this entire time. The thing that cannot be stripped away because it is the thing doing the stripping. And now the question that none of this answers. Does any of it matter? You have spent this entire time watching reality be disassembled, layer by layer, theorem by theorem. The brain lies. The world is empty. Facts are yours alone. Space is a projection. Time is a filter. Math has holes. And the only thing left is the awareness you are using to take this in. So what do you do with that? You could panic. You could decide that if nothing is real, then nothing matters. You could walk away feeling like the floor disappeared. But think about what was on that floor. Your deadlines, your debt, the argument you had last week, the thing you were afraid of, the thing you regret. All of it was sitting on a foundation that turned out to be empty. And if the foundation is empty, then the weight of everything on it is not what you thought. The problems that kept you up last night exist inside a model your brain built from predictions it never fully checked against a world that has no properties until asked. The things you are afraid of are facts that belong to you alone in a universe where facts do not transfer. The future you are anxious about unfolds in a time with no fixed direction, built on a causality that does not hold at the base. None of your problems are on solid ground. Because there is no solid ground. There never was. And honestly, that is the best news you have heard all day. Think about it. If nothing is fixed, then nothing is final. That mistake you keep replaying in your head, that fear sitting in your chest, that thing you think defines you, none of it is carved in stone because there is no stone. There is just you, right here, aware, experiencing this exact moment that the entire universe apparently needs an observer to create. Out of every possible configuration of matter and information across all of space-time, you are the one sitting here, conscious, asking questions, feeling something while you hear these words. Do you realize how statistically absurd that is? You're not just alive, you are the point where the universe opens its eyes. So stop waiting for the ground to feel solid. It never will. And that means you are free. Free to build whatever you want on top of the void, because the void does not care. It just responds to whoever is watching. And right now, that is you. Go live. Not because everything is fine, because everything is impossible and you are here anyway. That is enough. That has always been enough. Thank you for staying with Acronium through all of this. I want to hear what you think. Drop your thoughts in the comments. See you next time.